All right, ladies and gentlemen, our topic for this upcoming unit is all about proportional relationships. And we talked a little bit today about what proportional relationships are and how we can identify and use them. And the video tonight, the big main purpose is that you can recognize proportional relationships in a variety of different ways. So you can find out whether a relationship is proportional by looking at a graph, a table, or an equation. And I should also add, or a verbal description. A verbal description is just words. So when you have a word problem, you should be able to tell right away from that word problem whether it is proportional or not. So get this written down. Make sure you have the date and the page number as well. Pause the video to get that all written, and then we're going to move on. So we're going to start with looking at graphs, and you can keep this on that same page. I believe it's page 48. Keep it on the same page, and this is what you need to know. If a graph is a straight line, that right away should clue you in that it is a linear function, first of all, and it goes through the origin. The origin is that point 0, 0. It's at the very center of our coordinate plane. So if it's a straight line and it goes through the origin, then it is a proportional relationship. So let's say I have a coordinate plane here, and I've drawn a line that looks like this. Let me adjust that a little bit. Right there. That would be a proportional line, a proportional graph, because it is a straight line and it goes through the origin. If it's up like this, it's still a straight line, but it does not go through the origin, that center point on our coordinate plane, and therefore it would not be a proportional relationship. An example, you don't have to write this down. This is just something that I thought was kind of neat to show you how much getting a good education can make a difference in your life. If you look at this graph, it talks about the amount of money you make compared to the number of hours you work. So this is in a 40-hour work week, which is a typical work week for somebody. What you can expect when you graduate high school or graduate college and go into the real world. Let's start out looking at Bill Gates. Bill Gates has this straight line with actually a fairly steep slope, and he makes $451 each hour. Is this line a proportional relationship? Yes, it is. It's a straight line, and it goes through the origin. $451 an hour. That's crazy, isn't it? Now, a lawyer, somebody who has to go through an undergraduate degree of about 4 years, and then a law school degree, which is 3 years long, and then they have to pass something called the bar, is going to make $300 per hour. If we think about how much per week that is, it's between $10,000 and $15,000, probably around $12,000 a week. Next, we have a plumber, something you can get into after you graduate high school without really getting a lot of training, although there are some 2-year degrees that can give you training in that field. And if you are a plumber and you've been a plumber for a little while, let's say 5 to 10 years, you can make about $60 an hour, which ends up being somewhere around $2,000, although that's a little bit on the high end, $2,000 a week. Entry level, this is minimum wage. This is a job like McDonald's, or if you're fresh out of high school and you don't really have any training and you want to get a job in a factory or on a construction, you're going to be making $6 an hour. You can hardly tell on this graph where that would be each week, but if we think about $6 an hour, 40 hours a week, that puts you at about $240 every week compared to these other levels. So you know how I'm always talking about college and how important college is? This is why, guys, so that you can pay the bills when you graduate and when you have your degree, and you can actually get a good job that lets you do some things you enjoy. All right, let's go ahead and go on to the next page. That was a little side conversation. I just thought it was kind of neat to talk about. Whoopsie. On your next page, make sure you put the date and the page number 49. And we're going to look at how you can tell if something is proportional in a table. This is a table, like an XY chart. Not sure why it keeps doing that. If each ratio of one variable to the other variable is equivalent, then the relationship between the two variables is proportional. Okay, what on earth does that mean? What that means is if I look at my x and at my y, and I look at the relationship between those two things, and I set up a ratio, 3 to 6, 4 to 8, 5 to 10, and 6 to 12. If I were to simplify each of these ratios, all of them would end up being 1 to 2. Because each of those ratios are equivalent, that means that my two variables, x and y, are indeed proportional. Okay? And in case you were wondering how I got from this ratio to this ratio here, you simplify. What number can 3 and 6 both be divided by? Just like if it was a fraction, and you'd end up with 1 over 2. Okay, so how about you try one? I want you to take a minute, pause the video, see if you can figure out if this relationship is proportional. I'm going to count down from 10 and then reveal the answer. So make sure you pause and try and figure it out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so as you can see, I've made my ratios here in this column and then simplified them here. And none of my ratios are the same. And in order for the two variables to be in a proportional relationship, every single ratio here has to be identical. So this one is not proportional. Let's go ahead and look at equations. If a variable, this is fancy math speak, just bear with me. If a variable is the product of a constant and another variable, it is proportional. And we have here this kind of standard equation, y equals kx. And that equation is the equation for a proportional relationship. I'm going to write that little note up here. Equation for a proportional relationship. And if we look at this definition here, this crazy math speak definition, if a variable, that's my y right there, that's my variable, is the product, okay, so that's multiplication in between these two things, of a constant. Now, constant, as we know, is a plain old number. And if you look here, you might be saying to yourself, Mrs. Ott, there are no plain old numbers there. But actually this k, this is called the constant of proportionality, and it's always going to be a number. So it might be 1/2, it might be 6, it might be 10, but that's where they get the constant part in this definition. So if a variable is the product of a constant and another variable, that's our other variable, it is proportional. So we can look at some different equations and be able to tell right away if they're proportional. I'm going to have you ignore, not that one, this one right here. And let's look at some of these. Here we have an equation y plus x equals 7. Even if we were to solve this equation for y, getting y alone, like it is over here in this standard form, it would be y equals negative x plus 7. That is not a proportional relationship. Over here, we have y equals 4.7 times y. That is a proportional relationship because it's a variable, the product of a constant, this number 4.7, and another variable. Oh. It's not made a boo-boo. This is not proportional. Because, and you have to be careful, both of these variables are the same. Okay? So they have to be different variables in order for it to be a proportional relationship. There's actually only one equation on this page that is proportional, and that's this one right here. Y equals 3.5 times x. Two different variables and a constant. Okay? Um, we're going to skip the verbal expression. In the beginning of the video, we talked about we were going to find if a relationship was proportional and I had to add verbal descriptions. We're going to go ahead and save that for another day. And you're going to answer this reflection question. Does this table represent a proportional relationship, and why? I want a detailed explanation of why it does or does not represent a proportional relationship. All right, guys, have a great day, and I will see you tomorrow. Bye-bye.